I meant to talk about this in the last video, but I forgot, and I accidentally ended it too quickly. But how am I deciding what I'm using to compare it to? Well, I always know that I'm going to flip the second fraction over and multiply. If I take a series a sub n divided by b sub n, I'm going to flip this one over and multiply. So really, what I do is I'm just trying to figure out some series so that when I flip it over and multiply, I get the same degree on the top and on the bottom, so that maybe the limit is nice and easy to take. So that's what I'm going to do here. I notice that on the bottom, it's the square root of n squared. So the square root of n squared, that's just going to be n. So my b sub n is going to be 1 over n, because that's the square root of n squared. Now let's compare it. So I have this, n squared plus 4, and I'm going to multiply by n, right, because I'm dividing by 1 over n, anyway. And now I have n in the top, and n squared plus 4 underneath the radical in the bottom. Now if I take the limit as n approaches infinity, let's see what happens. Well, I think this one also goes to 1. But remember our trick. We can multiply by the square root of n squared. 1 over the square root of n squared. And I'm going to do that in the top and the bottom. Well, square root of n squared, that's just 1 over n. Those are the same. So if I multiply those two, I get 1 divided by, and then 1 plus 4 over n squared underneath the radical. This goes to 0 if I'm taking the limit as n approaches infinity, and then this goes to 1, which is L, and that's greater than 0. Thus, this series diverges, because this is a divergent p-series. Very good. See, very good. Maybe I'll do another example in this one. So that was example 2. Alright, let's take a look at something else. Alright, now on this one, I'm thinking, oh wait, I wrote it down wrong. There we go. I'm thinking, okay, how do I make this and this the same degree? That's my goal for right now. So let's see here. N cubed, alright, great. If I just had n to the 7th, I'm going to do this in a different color. N to the 7th there, and that was underneath the square root. That would be the same thing as n to the 7 divided by 2. Yeah? Yeah. So, how do I make this into a 7 over 2? That's the trouble here. Well, that's not that hard to do. So I would have to be, well, what do I want? 3 plus what gives me 7 over 2? 7 over 2 is a little bit more than 3, so plus 1/2. 3 plus 1/2, right? Because that would be times 2 times 2. Yeah, that would be 6, 7 over 2. So I need, and this is the part that I was talking about before, I need a 1 over, so I'm going to compare it with b sub n, which is going to be 1 over n to the 1/2. Now, when I do my actual comparison, I have n cubed divided by the square root of n to the 7th plus 2n squared plus 1. And I'm going to multiply by the square root of n. So I'll just multiply by the square root of n. Multiply, by the square root of n. I'm just going to say 1/2. Remember, I would divide by this, but that's the same thing as flipping it over and multiplying. So then what do I have? I already figured out that it's going to be n to the 7 over 2 over this, n to the 7 plus 2n squared plus 1 underneath the radical. Take the limit, and then see what I got. What do I have? Well, I can multiply by 1 over 1 over n to the 7th, all of that underneath the radical, and do the same on the top. So what happens? This and this just make 1. And then in the bottom, this becomes 1 plus 2 over n to the 5th, I think, plus 1 over n to the 7th. And all of that is underneath the radical. And I'm taking the limit. So what happens? This goes to 0. This goes to 0. And I get 1 once again, which is the same thing as L greater than 0. Sweet. Now, so I know that these two series do the same thing, and this is a divergent p-series. So this diverges. So the answer would be the series n equals 2 to infinity of n cubed divided by n to the 7th plus 2n squared plus 1 underneath the radical down there. Diverges. And that's because we're using the limit comparison test with a divergent p-series. And that's it. Good day.